Okay, so pre-calc, we're coming back with more terminology, terms before we get to the unit circle. We have a quiz coming up, so anything can show up. So the main thing that we're going to start with, and you probably remember that quadrant 1 starts in the top right, and I don't know how many of you thought about, well, why does that happen? Then we go counterclockwise. Quadrant 2, quadrant 3, and quadrant 4 in Roman numerals is over here. But it actually goes down to the unit circle, which is where we're headed, and we start on the positive direction of the x-axis, and we go counterclockwise. So we just think of it this way, that's fine. And right now we're just sticking with degrees. We'll talk about radians here in a second. So this is 90 degrees, 180. Well, if we go, and it might help you to write it out. 90 degrees is the right angle, 180 degrees is the straight line. So then 270 down here. Well, that's too far. So we're going to stop over here in the third quadrant. And I'm fine if you put a little arrowhead right here to say, hey, that's where we go. So then 575 degrees, again, we start out on the x-axis, the positive x-axis, go counterclockwise. Well, all the way around is 360 degrees. Well, we still haven't reached 575, so you just keep going. Continue on. So right here's another 90, that's 450. Here's another 90, so that would be 450 plus 90 is 540. I don't know why it took me so long to think of that. But then a little bit further would get me to that angle. So it's a full revolution and then a little bit more. More like a revolution and a half and then a little bit more. Okay, so what about if we have a negative angle? Well, we still start at the positive x-axis, except now we go clockwise. If you're unfamiliar, a clock goes around this way. That's what I mean by counterclockwise versus clockwise. So right here would be negative 90 degrees. And then negative 180 degrees would actually be the same as going positive 180 degrees. So a little bit less than that. Be over here. So you're given the direction that we're going. But the whole premise of this is that the three angles that we drew above look like they end in the same spot. I'm actually going to go to the answer key because I just want to use his terminology here. Is the initial side is where we start, just like your initials of your name, that's the start of your name, is the positive x-axis. And then where we end is called the terminal side. If you've ever heard of a train terminal, that's where the train ends. So, or an aeroplane has a terminal. It's where the plane finishes its flight. So they both terminate or end at the same place. Or all three of them, I should say. And the one thing I forgot to write down is the reference angle is the angle made. It's a positive acute angle that's made with the x-axis. So again, you might want to pause the video, write down these things. I didn't want to forget anything like I did. I forgot to write down that the positive acute angle made with the x-axis is called the reference angle. That's pretty important stuff right there. By the way, we call these three angles that end in the same place coterminal. Coterminal. The prefix co literally means the same in this instance. Not complementary. It means co, means the same ending place. And then the main difference between these three is the direction. Okay, positive angles go counterclockwise. Negative angles go clockwise. What was the second one? The number of quadrants the terminal side passes through. So what he's talking about there is, if you did a full rotation, there's 4 quadrants being passed through there, and then 3 more, whereas this one only went through 3, this one went through 2, to get to the terminal. Okay, so figure I might as well just keep going with the key words here. That way I don't forget to write anything down. So again, pause the video as you want. So based on what we've seen so far, there's 4 things that are pretty important about standard position. We always start on the positive x-axis. The standard side, I'm sorry, I said the wrong thing. The terminal side is pretty important. The way you rotate is very important. And then the 4th thing that I happen to forget is to label that reference angle. If you forget in the future, it's not that big of a deal. But you'll get used to it, trust me. And then I already gave you this phrase. The coterminal angles are angles that terminate in the same position, having the same reference angle, but different ways of getting there. Different, do you do a full rotation and then a little bit more, or do you go clockwise versus counterclockwise, things like that. So go ahead and pause the video as I get back to my notes. So the whole premise of this is getting you to think about, well, how could you get other angles? So if I were to ask you to draw negative 470 degrees, not too bad, starting on the positive x-axis, going clockwise because it's negative, negative 360 to get me here, negative 450, well, a little bit more to get to negative 470. So the terminal side will be over here. Again, the author of this stuff says it's really important to give the reference angle. It's not the biggest thing. So if you think about every one of these being 90 degrees and negative 470 was 20 more, like right here is 20 degrees. I don't really want to write that. What's left over for the reference angle would be 70 degrees over here. Again, it's not the most important thing, but we're getting there. So think about, well, what's another way that we could get to that same terminal? Well, what if we didn't do a full revolution and we just said, well, let's just do this kind of revolution right here. And some of you may already have the method of getting there, is if you're undoing a rotation, you can just add 360 degrees to it, because that's one full rotation. And by doing that, what you'll see is I'll get, first of all, it's a negative answer, and the difference between those two is 100 and, no. I don't know what's wrong with me. I had the right answer and I just didn't believe myself. Negative 110 degrees. And think about, well, if you went a rotation of 90 degrees, and then I erased it, but I had 20 more, 90 plus 20 would have gave me 110, but it has to be negative because we are going clockwise. Well, the positive version that we can do then is just take that answer we just got and do one more revolution. Now, I would actually do 360 minus 110. That's just how my brain works to get 250 degrees. But now we have a positive angle, and you can verify it. Let me draw it over here. It is 90 degrees, 180. Well, 270 will get me all the way over there. And you can verify that 70-degree reference angle. This is the reference angle. 90 plus 90 is 180 plus 70 would give me to that 250. And we're heading into a direction that we are going to get into radians, but we have to define radians first. But before we define radians, we have to define the unit circle, which you may have heard other students talk about before. The reason why we call it a unit circle is, well, first of all, it's a circle. We center it at the origin. With a radius of 1 unit, hence unit circle. So the reason why we name it this way is because I can ask you for the circumference of this. And in case you forgot the formula for circumference of a circle, it's 2 pi r. Well, if the radius is 1, well, that would imply then the circumference of a unit circle would be 2 pi times 1 for the radius. Or in other words, it's just 2 pi. So the distance, the circumference of the unit circle is 2 pi. So what we're showing, what we're deducing from this, is that if I ask you to go 360 degrees around a circle, the unit circle, we're going 2 pi radians around. So 360 degrees, so that's where we use the degree symbol, is equal to 2 pi radians. And you may remember I said you have to write degree symbol. You don't have to write out radians because it's implied. There's no degree symbol, so it's implied. And if you want to, you can write out radians. So sort of the premise that we're going to get to is, and the way this question's asked, I just don't like the way it's being asked, but it's saying if 360 degrees, it must be multiplied by some x in order to get to 2 pi radians. So if you're ever asked to convert, what they'll do is they'll divide the 360 over. I just don't like that. But the reason why this is kind of helpful is because this does reduce that pi radians is equal to 180 degrees. What you're going to hear me reference down the road is that if I ask you to go 180 degrees, you're going to see me write pi radians over here as well. And you'll also see me write over here that 360 degrees is equal to 2 pi radians. And for anybody in chemistry, or you did a pretty good job in chemistry, I like to just do dimensional analysis to convert. So let's say you're given degree measure. Okay, so I'm sticking with that orange color. You have something in d degrees. Well, if you want to convert from dimensional analysis, if you ever cancel out degrees, you have to put it in the denominator, and you put 180 degrees down there for pi radians. And then same thing is if you're given some value in radians, I don't know how I want to write it because you don't have to write radians out, but let's say you have some x value in radians. Well, if you're doing dimensional analysis, you would put the radians in the denominator to cancel them out, and it's pi radians for 180 degrees. Maybe I should clarify, but I'm assuming you know that you multiply in the numerator and you divide by what's in the denominator. The same thing where you multiply in the numerator, divide into the denominator. So as we look at a few examples, I'm not trying to rush through just to rush through, but if you're ever asked to convert and you're given degrees, well, you got to put degrees in the denominator then. Pi radians in the numerator. That way the degrees will cancel, and 90 over 180 reduces to 1/2, but you'll see me write the answer as pi over 2. And this should make sense. If I go back to this problem up here, and 90 degrees is this right angle, that's half of 180, right? So what does that mean for up here, the measure in radians? It needs to be half of pi. So it's pi over 2. And as we get more practice, this will become more, you'll be more fluent in this down the road. So same thing with the next one. 180 degrees on bottom, pi radians on top. Your answer is still negative, and you might just go to a calculator because your calculator will do this for you. Alpha x negative 235 over 180 and negative 47 over 36. And I'm running out of time, so I'm just going to jump to the answer key. He doesn't quite set it up the same way I do, but notice that the pi's will cancel. And I trust that you guys can work through this. If not, you can ask me in class. And it looks like I need to make a second video to finish up these notes.